Question number 6. I know it says that you're allowed to use a calculator. The calculator actually doesn't come in until the very, very, very last step. So the one that's on your benchmark you will not be able to use a calculator for, but you don't need it. And again, this one you'd only need it for the very last step. It says let f of x be an antiderivative of ln of x minus 3 squared over x. Antiderivative, again, is just the integral. So it's essentially take the integral of this and figure out what the integral is. And it gives us two initial conditions, or actually, I'm sorry, it gives us one initial condition, and they want us to figure out what f of 2 would be if we know this initial condition. So remember that when we take an antiderivative, we have to add c at the end. So this first initial condition is going to help us figure out what c is, and then once we know what c is, we can plug in 2 into the equation to figure out what the function equals it to. So first, let's concentrate on taking the integral of this. So hopefully it registers in your mind that we might want to use a u substitution, because this is probably something we're not very familiar with. So let me pull it up here so we can see how to do it. Alright, so for this one, I chose u to be what was inside the grouping symbols. So again, the grouping symbols in this case were here, so I chose u to be ln of x minus 3. So if we choose u to be that, ln of x minus 3, the derivative of ln of x is 1 over x. And the derivative of negative 3 is 0, so that goes away. Again, I only show you guys, obviously, the ones that work. You might choose some first that don't work, and when they don't work, that's fine. Just erase it or cross it off and try a different one. So you don't have to always get it on the first shot. Just try many of them until they do work. Here's why this one does work. The ln of x minus 3 helps me to replace everything in here. The 1 over x dx helps me to replace this dx and this x that's on the bottom, because that would be 1 over x. So I like that. That helps me get rid of that. So when I do those replacements, the ln of x minus 3 becomes u squared. And then the x on the bottom with this dx is just replaced by du. So that's where I got that from. The integral of u squared is u cubed over 3 plus c. And then when I plug u back in, I get ln of x minus 3 cubed over 3 plus c. So that's the actual function. If the question just said find the actual function, we would be able to stop there, because that would be the final answer. But it does not say find the actual function. It actually says go back and find f of 2. And they gave us this initial condition. They said that when, let me write this right here. They said that when f equals, they said f of 1 equals 2. So that's where this initial comes in. 1 is right here, and 2 is right here. So the function should equal 2 when x equals 1 is what this initial condition says. So I plug in 2 for the function, 1 for x, and I simplify. The natural log of 1 is 0. You guys should know that off the top of your head. That's not even a question. So you definitely should not need a calculator for that. I would expect you to understand how to do that in your head. So the natural log of 1 is 0. 0 minus 3 is negative 3. Negative 3 cubed is negative 27. So now I have 2 equals negative 27 over 3 plus c. Negative 27 over 3 is negative 9. Add 9 to this side and you get 11. So we know that c is 11. So now if I come back to my equation again, now I want to evaluate what f of 2 is. Okay, so in order to figure out what f of 2 is, here is where you finally need the calculator. You did not need a calculator before any of this. So you have to actually plug in ln of 2 in a calculator, because you could not figure that out. Subtract 3 from it, cube it, divide by 3, add 11. And the answer is 6.908. So if you put that in a calculator, that's what you should get as well. Just a little hint. Remember I said that you're not allowed to use a calculator on the actual benchmark? You can evaluate x values of 1, for example. So if you have the natural log of 1, you could do that. That's 0. You can evaluate ln of e. ln of e is just 1. And you can evaluate ln of e to any power. ln of e squared would be 2. ln of the square root of e would be 1/2, so on and so forth. So on the actual benchmark, you will have something that you will be able to evaluate without the use of a calculator.